Thanks everyone for coming to our third UV Cyber webinar. I'm excited today to talk about Electron application security. My name is Aaron Haymore. You can hit me at Zonifer on all of the socials. And I do offensive security training at UltraViolet Cyber. I also support our continuous penetration testing team, and I also support our point-in-time penetration testing team. I have a semi-diverse background. I got my career started off at NCC Group doing zero-day vulnerability disclosure. And then I pivoted to Merrick Banks and Cardwork Services doing more offensive type work, such as PCI penetrations test, offensive security, red teaming, all of anything under the sun that's offensive I was doing for them. And I'm also a adjunct professor at Ensign College located in Salt Lake City, Utah. I wanted to give a brief introduction to UV Cyber. Some people might not have heard of our company. Really, the purple came from blue and red, four companies coming together, offensive security, threat exposure management, dedicated defense, and 24-hour SOCs. All these four companies came together and formed UltraViolet Cyber. So if you have defensive needs or offensive needs, we can meet both of those. This is some more of our services at a glance. We have some teams based out of India and then all across the United States. We have close to 400 employees, over 1 million managed assets, 20 years of operations, and then some more statistics on the screen if you want to take a look at that. So getting kind of into the meat and potatoes of this webinar, I'm going to talk about Electron applications. There's been a lot of talk and buzz going on recently about Electron applications and their security. If you're on Twitter or Reddit or any Discord, there's been a lot of buzz about Electron apps recently. And sometimes when there's a lot of buzz and cool things come up, it's cool to be like, oh yeah, that's awesome. But in this webinar, I'm kind of wanting to peel it back just a little bit to help you understand what an Electron app is and some of the common exploitations that are being done on them right now. So prior to a lot of this buzz, I heard about Electron applications, and that was really about it. But Electron started way back in 2013. That was when the first commit started. And as a whole, it is a framework to help build desktop applications. It's a framework to help you build like a Chrome or a Discord or your own Obsidian note-taking. It's just a framework that you can use to build some type of program. And Electron is interesting because instead of building it in Java or Python or C++ or .NET, it actually uses JavaScript. And this has a lot of advantages for it as well, because if you want to start developing a new application, and you're already in the web space, you don't have to go out and hire new developers, or you don't have to train up your existing developers. You can use their existing skills in JavaScript to go and build this new desktop application. It's really just like an application running in like a Chrome-like thing. And it has a couple advantages I've listed here on this slide. It's cross-platform, so you can package up your application. You can ship it to Windows, you can ship it to Linux, you can ship it to Mac OS. And that's really nice with it. It's got a really fast development cycle. It's basically just doing front-end web development, this Chrome-like application. And because it's in JavaScript, it's got a huge library support. So all these cool things that you can do in the web, you can do on your desktop applications too. And like I mentioned, if you've got a lot of JavaScript developers, or generally speaking, there's a lot of JavaScript developers out there, you can take them on to start building Electron apps for you. At a high level, this is how the application works. You've got your Node.js project, and you can have your HTML and your CSS to make it look like how you want it. And then you can package it, and when you run npm run make, you can take your project that you've created and you can build it for Windows, Mac OS, Linux, whatever you want. It's just like you're coding in the web, but now it's a cool desktop application. And there are a lot of applications that you've probably used this week that you didn't even know were built using Electron. Cursor is a really popular one right now. It's like an AI coder. I know a lot of folks use Discord, Teams, Slack, Arduino, tons of different IDEs, Postman, Obsidian note taking. All of these are built off of Electron, or they use it in some port. So it's really common to have applications that are built on top of Electron. So as an attacker, let's look at some attacks that are common within Electron apps. The first one that I want to talk about is debug mode. So when you go and you've got your application, whether it's like this full built application that you're ready to ship out, or maybe you're just playing with it on the side, there's a certain flag that you can specify or not specify during the build process for debug mode. And back in 2024, there was an Electron application that got built with this debug flag set. And when this debug flag gets set, you can bypass a lot of the consent and control restrictions on Mac OS. And it's super easy. When you open up the Electron app, just like you would on a normal Mac, on the top left-hand side, usually like where you see edit, view, window, help, all that sort of jazz, there was like a debug section. And you can go and debug it like a developer would debug it and bypass some of the controls on Mac OS. So if you're looking at Electron apps, you definitely want to look at seeing if debug mode is there as well. They're also vulnerable to injection-based attacks because this is primarily a web app running in an application. They're vulnerable to your normal cross-site scripting and code injection. They might not be as prominent as they were like running on the web. You can't like do an XSS with someone and steal their cookies, but it opens up some potential for some code injection. And then there's also some dynamic library hijacking that you can do as well. So I wanted to break it down just a little bit more and show kind of what that build process is of creating a Electron app and kind of just how that whole process works. So on the left here, I've got a application called main.js. And all this does is excuse me, it's got a function that will just create a window and it's going to load this index.html file and it's going to load an external resource called sample. So when the application runs here at the bottom, it's going to create a window and load the contents of index.html, and then it's just going to run our sample function that's getting imported from this third line. This is the index.html file. It's just a super basic HTML file. It says my Electron app, hello from Electron. And then I mentioned before here, there is this, this sample function that's going to be doing something. This is just for demonstration purposes, but this could be maybe loading something from the back end or whatever function that you want to add into your application. So this is just my external function. It's example.js. It's another file on the file system, and you could put information or whatever you want to do in here, you'd put inside of this function. And then this module.exports, it's just exporting this so that it can be used in other files. So this is the entire project. There's 3 files, main file, the index.html file, and some external script resource that we're using inside of our main. And when we build and run this, this is what we get. So you can see it's just like a normal application that you'd see on a Mac, and it says hello from Electron that was defined inside of index.html. And that's at a high level how these Electron apps work. So I want to talk about one type of attack that you can do called script jacking. And this happens when you have the ability to edit some of these JavaScript files. So in this example, I am editing that sample.js file. So as an attacker, I've got access to write to this example.js file. And instead of just doing something normal that is part of the business process, I'm doing something a little more malicious. I am importing this child process, and I am doing some execs here. So when this function is ran, it's going to execute the command who am I on the system. So when this application gets built and ran, it's going to output the contents of that command. In this example, I'm just doing like a who am I to show that I have code execution, but from here, you could get a reverse shell on the system. You could put an implant, you could steal cookies, whatever your target is on this machine, you can run those commands if you have access to write to those JavaScript files. And this isn't super new. This was discovered back in 2022. And there have been a couple real world scenarios that this has actually happened to. There's a popular application in China called MimiChat. And Iron Tiger had compromised the server that was hosting this code. Iron Tiger has tried to attack MimiChat several times. And historically, before this, they were trying to host their servers and try to force people to download their version of MimiChat than the actual. But in this example, they actually compromised those servers that were hosting this code, and they were able to backdoor their own malicious code inside of this MimiChat application, similar to how I showed before. So when they would build this application, their malicious JavaScript would get ran in conjunction with the legit normal code that's supposed to be in there. Excuse me. And some of this code, it's going to collect information and send it back to the command and control server. It's going to receive commands from the command and control server and execute them, and then push that back up to the command and control with Iron Tiger. So this is the real world scenario that actually happened. One of these Electron apps got backdoored and malicious JavaScript got inserted, and now the attacker can do what they want to whoever downloads this application and runs that code. Because of this, there have been some fixes and things that defenders can do to help prevent this type of attack. The first one is integrity checks and ASR checks. So when you have your JavaScript code, these integrity checks are making sure that it hasn't been modified by an attacker or someone wanting to do something malicious. ASAR checks or Atom Shell archives. These are files these are artifacts that happen when you build your Electron app, and they get signed. It's kind of like a tar file, but it's designed for fast read access, and there's no compression. And you can put checks on those files to make sure that your Electron application hasn't been backdoored. And then on Windows, there's WDAC, and you can use this to an extent. So for example, maybe you found a vulnerable Electron application and you write in your malicious code and you want it to execute your binary or your executable. If WDAC is enabled and configured well, when that Electron app runs, your binary isn't going to get run. But there's a couple workarounds with that you can do as well. Some of those workarounds and some of the sneaky things that have been done are within low-key C2. This is a cool C2 that's been going around recently, where it's a full command and control server and it's all written in JavaScript. So instead of having to reference external binaries or this or that, the low-key C2 puts all of that malicious C2 code inside of those JavaScript files directly. And then there were also some detections that were written for this. There's a couple Sigma rules that you can reference for this low-key C2 here. And then another interesting thing is the low-key C2, it uses Azure storage blobs for the communication back and forth. So if your organization doesn't usually use Azure storage blobs, this would be a good detection because, right, if your organization isn't using Azure storage and all of a sudden one of these Electron apps is accessing Azure storage, that's kind of out of the ordinary. That's kind of weird. And then Electron apps also reaching out to these blobs is also pretty out of the ordinary and don't really happen. Really quick before the Q&A, I wanted to give a couple credits out. A lot of this research wasn't my own. I'm just presenting it. Bobby Cook at IBM has done a lot of super awesome work with this. Mr. Docs, Andrew and Ruben, they have been really the pioneers of these techniques and procedures. And it was really awesome to learn from them and share this information with you as well. We've got about 5 minutes before the webinar is over to do some questions and answers. Kaylee, have there been any questions in the chat? I think that we had a Q&A set up.
There hasn't been so far, but feel free, anyone. Open. Or you can raise your hand and I can take you off mute if you'd like to ask it in person.
Okay, if there's no questions, oh, yeah, Edgar. Kaylee, can you take Edgar off mute? I think he's got his hand raised.
Yeah, I think Edgar, you can go ahead.
Sorry about that. Hey, yeah, just wanted to share. It looks like the Q&A widget ran into a problem for myself. Not sure if it's happening for anybody else. That might be why we're not getting questions. But Aaron, was curious if you could say more about the integrity checks you had mentioned. What do those look like and how can those be implemented?
Yeah, sure. So some of these integrity checks, like I mentioned before, if you're a developer, for example, when a lot of these, since this has been getting popular, different developers have been putting in this ASR integrity check. So when an Electron app is built, this integrity is not there by default. It's not like I'm going to go build my application and it's super secure. These checks are already here by default. When you're doing the build process, there's a flag that you have to specify. And then it will put those integrity checks in place when you go ahead and build that application. And then if those files are tried to be modified, it's not going to work because that flag was set during the build process. You can also sign your files as well if you have a code signing certificate. So then if those files get modified, they're going to be invalid anymore. And hopefully an attacker doesn't have access to your code signing certificate as well. And then WDAC, like I mentioned before, if it's a more script kiddie type attacker, if you have a really strong, whitelisting process for what applications can and can't run, it might be harder to bypass some of those restrictions because you can't run my malicious code.exe, right? You've got to go through and do a little bit more work that some of those lower level threat actors might not want to do or might not have the skills to do.
All right, Edgar mentioned that there might be an issue with the Q&A. So if there's any more questions, just raise your hand and we can get to you. Oh, Aaron, there's one in the chat here from Suman. Do we have any mind map for testing Electron apps?
I don't have any right now, no. I usually just try and Google it and look at references online, but we definitely can build a mind map. I don't think that would be too hard. Looks like there was another question by Tanner. It says, hey, Aaron, Any other piece of security advice for a student who uses a few common Electron apps like Linux, Teams, and VS Code? Yeah, I think as a student, it would be a super cool project for your resume to go and maybe build some sort of small detection system on your machine to see if if something were to happen, you can go and trigger an alert. Or in a lab, you can go and deploy like Elastic or whatever and write some rules to detect if your Electron app has been backdoored by Loki C2, and then go and backdoor it yourself, and then look at those alerts and look at the logs and see kind of what's happening, and getting some more of that hands-on experience, I think would be really invaluable. Okay, I think if there's no other questions, we can go ahead and wrap it up. I appreciate everyone taking time out of your busy day to come and listen to my spiel and learn a little bit more about Electron apps. So thank you so much.